13. Why does phosphorus has a higher ionization energy than silicon? Well, phosphorus, if we do the configuration, we get P3. Silicon will be P2. So phosphorus will have one more proton in its nucleus, so there will be a greater effective nuclear charge. So A is the answer. Right. The atomic radius, option B, atomic radius of phosphorus is greater, is actually smaller because of the higher effective nuclear charge. So it's harder to remove that electron. Outer electron is more shielded. The shielding effect is about the same. They're the same period. They have the same inner electrons. So shielding effect is comparable, similar. Outer electron of phosphorus is paired. If you draw the configuration, they are all unpaired electrons for phosphorus and silicon. So that's why the other three options are incorrect. 14. Magnesium nitrate is heated. Three gases given off. First of all, the water of crystallization will be released as water vapor, and then we have our magnesium nitrate decomposing. When the nitrates decompose, we get nitrogen dioxide and oxygen gas. So we have a total of three gases: nitrogen dioxide, oxygen, and water vapor. Ammonium sulfate oxidize, producing sulfuric acid, nitric acid, and water. So we try to form an equation putting 1 mole of ammonium sulfate. We will see that we need 4 moles of oxygen. Okay, and balancing, we will require 2 of nitric acid and 2 of water, and then we'll get our 4 moles of oxygen here. We have sodium iodide. When we add silver nitrate, we will form silver iodide. So a precipitate will form. If we add concentrated aqueous ammonia, silver iodide is insoluble in concentrated aqueous ammonia, so the precipitate remains. In comparison, if we have silver bromide or silver chloride, these two precipitates will be soluble in concentrated aqueous ammonia, okay, but not silver iodide. Which one describes chlorine, bromine, and iodine? The bond energy will decrease with increasing proton number. It's easier to break up the bonds as we go down the group, okay, because of the longer bonds. First ionization energy should be increasing. Nope, that's wrong. The first ionization energy should be decreasing because we get bigger and bigger shells. As you go down, it's easier to remove the electron. They're all colored gases. That's wrong. Bromine is liquid. Iodine is a solid at room temperature. They are good oxidizing agents. They themselves tend to be reduced, so they will oxidize others. 18. Why do we use sulfur dioxide as a preservative in jam? Okay, because they are reducing agents, and your aerobic bacteria will not be able to grow well when there is no oxygen, when the environment is not oxygenated. So the reducing agent prevents the environment from being oxygenated. Okay. 19. What property is typical of its element? So all these are the properties of beryllium. It does not react with water. That's not typical of group 2 metals, right? The other group 2 metals are pretty reactive. BeCl2 is covalent, that is correct, but the others, the chlorides, are typically ionic. Beryllium nitrate will produce beryllium on decomposition. That one is correct. Okay. Beryllium oxide dissolves in alkali. That is true, but because it's amphoteric. For the rest of the group 2 oxides, they are actually basic. They will not dissolve in alkalis. So C is typical of group 2. We have a polymer. How can we get the monomer? We will have to look at the repeating unit. Repeating unit can be viewed as this one, okay, or this one is the same, or the third one, no difference. So I just take one as example. This is the bonds that forms during addition, polymerization. That means before the polymerization, there was a double bond between these two carbon. And we compare to the options we have a CH2, a CH, and COOH. So this was the monomer. Right. And when it forms a polymer, the double bond will be gone, right, and a new bonds will form to the next monomer here. Compound X reacts with ethanoic acid to produce the compound below. So this is an ester. Pick up the ester bond here. So if you were to reverse back, you cut the ester bond. This part on the right side comes from your ethanoic acid. So the left side is the one that we are interested in. We form back the equation, or form back the molecule. This was the alcohol part, so we replace it, the H, back to its molecule. So this is the original molecule. (22) Which could it be that has all these three properties? Ethanoic acid, liquid at room temperature, mix well with water, and then reacts with your alkali. Okay. Your ethanol does not react with your alkali. Your ethene is a gas, not soluble in water, and no reaction with sodium hydroxide also. Your ethyl ethanoate is not soluble in water, or not very soluble in water. So left us with A. (23) We start off with this molecule, 2 carbons, we end up with 4 carbons. So there must be a step-up reaction along the way. This is carbonyls. So we will use hydrogen cyanide with NaCN as a step-up reactants. And once we step up, we'll get this cyanohydrin. To change this CN to a COOH, we have to use hydrolysis, okay, acidic hydrolysis. So we step up first, and then we hydrolyze the CN to form COOH. Which alcohol only gives only one possible oxidation product with your oxidizing agent? So we go down the group. Butanol will give us butanol, your aldehyde, and butanoic acid, 2 possible products. That's out. Buta 2-ol will give us butanone only, it's a ketone. 2-methylproper-1-ol will give us 2-methylpropanol and 2-methylpropanoic acid. The option D is actually a tertiary alcohol. It will not be oxidized. So only buta 2-ol give us one product. (25) What product is formed when we have the molecule reacting with liquid bromine in the duct? So the bromines will be attached to your double bonds, and the double bonds will become saturated. So we have here we have a bromine, and then this double bond will have a bromine also. That will give us molecule B or D. Lactic acid, what is this property? It can decolorize bromine rapidly. That's not true because it doesn't have any C double bonds. So that's out. It is insoluble in water. It is actually soluble in water due to the possible hydrogen bonding over here and the hydrogen bonding over here. So it's soluble in water. It cannot reduce Felling's reagent because there's no aldehyde group. Okay. Two molecules react with each other in the presence of a strong acid. Well, it can undergo esterification. It has an acid group, it has an alcohol group, so it can react on its own. Either this acid with an alcohol, with its alcohol side, or this alcohol with its acid side on the other molecule, and then you'll get esters formed. (27) Which compound will undergo nucleophilic addition? We are looking at our carbonyl homologous series, WB. (28) Which compound undergoes SN1 substitution reaction? We are looking at our tertiary halogen alkanes, SN1. So we go down the list. Okay, this is a primary and primary. The tertiary halogen alkanes will be here. Right. This chlorine is connected to a carbon that's connected to 3 other carbons. For SN2, for comparison, SN2 will be usually our primary halogen alkanes. (29) We have C4H8. This is one possible compound. How many other possible compounds will contain a double bond for C4H8? So we do all the combinations. The double bond could be at the first and second carbon. Okay, but it's a straight chain. The double bond could be between the second and the third carbon, and then from there we have to check whether there's a cis trans possibility. So this is the cis isomer, and then we have the trans isomer from here. So besides this, we have 3 other monomers.